Hi, engineers. If you failed your last coding interview, then you're in the right place for practice. So, let's solve another classic interview problem, climbing stairs. Here's the problem. You are climbing a staircase. It takes n steps to reach the top. Each time, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Let's rephrase it in plain English. Think of all the sequences of 1 step and 2 steps that add up to exactly n. We count how many different sequences there are. First, let's set up 3 example inputs so we can test them later. We create a variable named n1 as 2. Then, we create a variable named n2 as 3. And finally, we create a variable named n3 as 5. How do we solve it the beginner way? We use dynamic programming. Here's the quick idea of DP in simple words. We build answers from smaller answers and reuse them. The number of ways to reach step I equals the ways to reach step I minus 1 plus the ways to reach step I minus 2, because the last move could be a 1 step or a 2 steps. We will store these counts in a table so we never recompute the same thing twice. Here's the code for the first solution. Let's create a function named climbDP that takes one input named n. Inside the function, we create an if statement, where if n is less than or equal to 2, we return n, since 1 maps to one way and 2 maps to 2 ways. After that, we declare a variable named dp and set dp to a new list with length n plus 1. Then we set dp at index 1 to 1, and we set dp at index 2 to 2. Next, we start a for loop. Inside this loop, we declare a variable I starting at 3. We keep going, while I is less than or equal to n, and after each round we increase I by 1. Inside this loop, we also set dp at I to dp at I minus 1, plus dp at I minus 2. After the loop finishes, we return dp at index n. Now, let's test this solution with our variables. We write a console log of climbDP of n1, then a console log of climbDP of n2, and a console log of climbDP of n3. When we run the file in the terminal, the expected results in this order are 2 for the first one, 3 for the second one, and 8 for the third one. Now, let's create a more advanced and space-efficient approach. This is just the same recurrence, but we don't need the whole table. We only need the last 2 values at any time. This is the Fibonacci pattern. Quick idea in simple words. The count for each step is the sum of the previous 2 counts, so we roll the values forward with 2 variables. Here's the code for the advanced solution. We create a function named climbFib that takes one input named n. Inside the function, we create an if statement, where if n is less than or equal to 2, we return n. After that, we declare 2 variables named a and b. We set a to 1 for step 1, and we set b to 2 for step 2. Next, we start a for loop, where we declare I starting at 3, and we keep going while I is less than or equal to n, and after each round, we increase I by 1. Inside this loop, we declare a variable named next and set next to a plus b. Then we set a to b, and we set b to next. After the loop finishes, we return b. Now, let's test the advanced solution with the same variables. We write a console log of climbFib of n1, then a console log of climbFib of n2, and a console log of climbFib of n3. When we run it, the expected outputs are the same as before: 2 for the first one, 3 for the second one, and 8 for the third one. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.